Dr. Narda here, back with another video. And in this video, we're going to talk about experimental designs or research designs with manipulated variables and random assignment. We're also going to talk about quasi-experimental designs, and these differ a little bit because they have pre-existing conditions where you can't randomly assign somebody. We're going to talk about the difference between internal validity, and that's the extent to which a researcher can be, adequately sure that there's a cause and effect going on, and the higher the internal validity, the better. External validity is about generalizability, or how can you apply your study to other findings. We're also going to talk about types of error. We're going to talk about type 1 error, or incorrectly rejecting the null hypothesis when it's true, and type 2 error, failing to reject the null hypothesis when it's true. So what are the conditions for good research is the first thing you want to consider. And the really big question comes down to, you want to make sure that your question is worthwhile asking. Does it add to the larger literature? Does it add to the field? If it does, then that's the question you go with. The second question, after you decide what your research question is to ask yourself, what is the best research approach to address this question? So the research question you pick will drive your research design. And there are different types of research designs that we can talk about. First is exploratory research, and that's really trying to understand a topic and not really formulate a specific hypothesis. It's just trying to explore a topic and maybe get some better understanding about that topic. And usually with exploratory research, researchers will use interviews, maybe focus groups, maybe case studies, or even surveys. And some of this exploratory research also falls into the guise of qualitative research. And that differs a little bit from quantitative research, where you're really collecting data and numbers. Qualitative research, you're collecting more so holistic answers on like interviews and maybe doing a focus group, and you're trying to look for themes and patterns that emerge as opposed to just quantifying data. And the thing you have to consider when you're doing exploratory research is factors that influence people's responses, right? So just by merely sitting somebody in a room and asking them questions, that could affect how they respond to you. They might have some social desirability. They don't want to be that open with you, that honest with you. So maybe they kind of lie a little bit, or maybe they don't want to be judged if you're doing an interview. It's also how you frame the question and the skill of the interviewer. So that really comes into play here. And again, you have to be very wary about biasing or affecting responses, because you want them to be as genuine as possible. The other thing you have to consider is this continuum of certainty. So generally speaking, the more control over your study you have, the more certain you can be in your results. We kind of refer to that as internal consistency. And we'll talk about what the gold standard for that is, which is experimental design. But we think about this as the level of certainty in the results related to conducting our study, related to the degree of control. Now, if you want to be on the lower continuum of control, you might want to do a non-manipulative strategy, like handing out surveys, right? So you might hand out surveys with a Likert scale and ask people how they feel about certain things or their opinions, or rate their interest on something. Now, this is just survey design, and without manipulating anything, you can't really infer causality from it. And these kind of research that are just survey design are high in what we call external validity or generalizability. And they're very low on internal validity because you're not manipulating anything. To really infer causality, you need to manipulate variables. The gold standard is experimental research, with the runner-up being quasi-experimental research. The more variables you can control, the higher internal validity you'll have. And if you add things on like random assignments to wash out group differences, and you can do manipulation checks, this will give you a very high degree of control. So you can be very certain about your responses. Now, correlational research, that is approach to research where you're not manipulating any variables. So again, we can collect data using surveys. Often this is correlational research. And basically you're focusing on the relationship between variables. So what is the relationship between variables? Because there's no manipulation at all of the variables, there's no opportunity to infer causation. So you cannot infer causation at all. Also, you're lacking random assignment. So you do not randomly assign people to groups. Groups are already pre-existing, so there could be group differences. And you can't rule out a third variable. So often with correlational research, there might be a third variable or intervening variable, we call it, third variable problem. Like if I told you when ice cream sales go up, so does the crime. And you might say, well, ice cream sales maybe are causing crime, or maybe crime is causing ice cream sales. None of that would be true, and you can't actually say that. There's actually a third variable, which is summertime. So ice cream sales go up in summer, and so does crime go up in summer. So you have to be very careful, because with correlational research, you cannot rule out a third variable. The only way you can rule out a third variable is doing some kind of experimental manipulation or some more advanced statistical analysis, which we do not cover in this video. So the question is, if you don't have a high degree of control, why conduct correlational research? Well, again, as I said, it's kind of exploratory, right? You want to see if relationships exist before investing a bunch of time, money into an experimental research study. You also maybe want to get a better understanding of the phenomenon, and possibly there's really no way to manipulate variables. Sometimes it's unethical. If you think back to the IRB video I put out, sometimes it's unethical to manipulate variables, or you can't ethically assign people to groups, right? So you can't ethically assign this person to that group. So you have to do a study with less control. Now you have to be very careful with your language. Do not use words that suggest causality, right? So you cannot say this causes that. You can only use words like there's a correlation here, there's an association here, there's a relationship here, maybe there's a correspondence, right? But you cannot use any words that might infer causality, like impact or influence or control or shape or alter or modify. Do not use those words. So make sure that you remember back from your early stats courses, or if you haven't taken one, correlation does not make causation. Now, the gold standard, as I mentioned a little bit earlier in this video, is a true experiment. And this type of research approach, you manipulate one or more variables, and you have what we call random assignment, meaning participants have an equal probability of being in either condition. Let's say there's two conditions. They'll have an equal probability of being condition 1 or condition 2. Sometimes you cannot do that. So you'll have to do what we call a quasi-experimental study, potentially, especially if you have pre-existing groups. So for example, if you have people that are married or not married, so if you're looking at marital status, or if you're looking at drinking coffee or not drinking coffee, or if you're looking at gender or sex, male, female, then you cannot randomly assign person to being married or not married, or being a male or a female. So here we have pre-existing groups, and often instead, since we lack true random assignment, we might end up doing a quasi-experimental approach. So there are some hallmarks of true experimental approaches, which is a couple different ones we'll talk about. One is between subjects designs. Now you'll hear this term, between subjects design. So what am I really saying when I hear between subject designs? I'm saying the condition of experiment are divided across participants. So you have, let's say you have 40 people in your study and you have two conditions. You have 20 people in condition 1 and 20 people in condition 2. And they serve, different people serve in each condition. Now within in-subject design, you have the same people serving in both conditions. So if you have 40 people, you'll have 40 people in condition 1 and 40 people in condition 2. How this kind of works is they'll serve in both conditions, right? The issue here, though, is sometimes there's something we call carryover effects that happen. So if you're in condition 1, you might learn something, or the condition 1 might affect you, and you might can carry that on to condition 2. But the plus within subject designs is you need a lot less participants. And sometimes getting a lot of participants can be challenging. Couple other words I want to just clarify for everybody so we're on the same page. You'll hear me use the word independent variable. That's the variable that's being manipulated in experimental designs or quasi-experimental designs. You'll hear me use word dependent variable. That's the variable that's being measured. That's the variable that's impacted or manipulated by the independent variable. And if you hear the word cause and effect relationships, you're thinking the cause is the independent variable precedes an effect, and the effect, the dependent variable, reflects the impact of the independent variable and its outcome. And again, sometimes you'll see quasi-independent variable. And again, that's, as I mentioned earlier, that's a naturally occurring variable like sex or political affiliation, something where you can't randomly assign somebody to a group. Now, there are various types of research questions, correlational research designs. So you might, in these types of research designs, you're probably going to ask questions about relationships. Remember, there's no manipulation here. So remember that you're usually saying, is there a relationship between group A or group B? Or are these two variables or these two groups correlated potentially? So it's all about relationship. Now, quasi-experimental designs, you might be asking a question about if group differences exist between a pre-existing group and another group, potentially. Experimental research designs, you ask a question about group differences and you create these groups through manipulation. With quasi-experimental designs, there is no manipulation. You're asking about group differences, but the groups are already pre-existing. Now, statistical analysis varies. So at the very base of the analysis, if you're doing correlational design, you might do a Pearson's R. Quasi-experimental designs, depending on how many groups you have, let's say you have 2 groups, you could do an independent sample t-test if you have 2 independent groups. Experimental research designs, if you have 2 independent groups, you might do independent sample t-test. If you have participants serving in 2 conditions, you might do a dependent sample t-test. That's with 2 groups. And if you have more than 2 groups, you might do an ANOVA. And it gets more complicated as we go, and we'll cover more in different videos. Now you might be asking yourself, what the heck is this error thing about? So we'll briefly cover this, but what you do as a researcher is you set your alpha level. And this is the likelihood of making a mistake. Often we set our alpha level at 0.05. Basically, we're saying there's a 5% chance that I'm wrong. However, I'm 95% confident that my answer is correct, or that my results are real and not due to chance, I should say. So there's a 5% chance I'm wrong. Conversely, there's a 95% chance that my results are genuine and true and not due to some, error. So you can be more confident. One thing to keep in mind is when you raise the alpha level, that directly affects type 1 error. It lessens it. However, it increases type 2 error, which we'll talk about here in a little bit. But we directly control for type 1 error. And sometimes researchers do a Bonferroni adjustment. And this is a way to kind of decrease type 1 error. You'll see this when you do follow-up tests as you learn more about statistics. If you do a post-hoc or a follow-up, we often do a Bonferroni adjustment to control for inflated type 1 error. Now, one-tailed significance test really comes down to the research question and what you're looking at. If you're predicting a relationship, if you're saying this group does better than that group, it's a one-tailed test. And basically, you're looking at only one region of the distribution. A two-tailed test, you're not stating where the difference lies, but that there is a difference, and you're looking at both areas of a normal distribution. So what really affects error, especially type 2 error, because I mentioned that earlier, right? So what really affects type 2 error? It's really sample size. Usually the larger the sample. So what really affects type 2 error? It's really about sample size. So generally speaking, you want to have an adequate sample size, and you could do what we call a power analysis before you run your study. But what you really want to do is, if the larger your sample, generally the less of a risk of making a type 2 error. The other thing that affects type 2 error is threats to internal validity. And This is maybe there's participants who talk to each other during a study, or maybe your instruments aren't very good and you pick bad instruments, or maybe you don't have enough people, so you have low power, or there's something goes wrong with your equipment. This all affects internal validity. So certain things threaten internal validity. And basically, these are factors that undermine the ability of your research to ascertain the influence of an independent variable on the dependent variable. Some common ones that affect internal validity are history. So something outside the research study, outside the experimental control, influences the results. Maturation occurs. Basically, the capabilities of the participants may change as a result of like fatigue, illness, their age, hunger. So things change. And then testing. Often when you test somebody more than once, they will end up doing better. Or if they do really good at the first one, we call, sometimes what happens is there's something we call regression to the mean, or they kind of do worse, so they move more towards average. So testing multiple times can also influence the results. Other influences on your study are demand characteristics. And these are cues to the participants in the study that maybe enable them to determine the purpose of the study, which again would maybe affect their behavior. Sometimes we do things not purposely, but subtly, and we might give people an idea of what our study is about. So there are many different forms of cues, like the attire of the researcher, like if they're wearing a lab coat or not wearing a lab coat, the manner of speech, where you're looking, so your eye gaze. There's a lot of different qualities that might affect or give people cues. Maybe the physical testing site, the size of the room, maybe if there's only one gender in the room, they might kind of figure out what you're doing. So we want to make sure that we remove these demand characteristics. So often what we do nowadays is actually computerize things, and we have set directions. So everything is basically very scripted. So that way we do not inadvertently do something that would influence our participants. Single blind study is a research design in which a participant are unaware which conditions they have been assigned. However, the researcher knows. A double blind study is where the researcher and the participants do not know which group they're in. Now, usually with experimental research, we like to do double blind. That way you don't inadvertently influence or provide demand characteristics on the participants as the researcher. And this removes those potential role attitude cues that could creep in. So if you know what group someone's in as the researcher, you might act differently towards them. So if we do a double blind, we can remove that. Another thing I want to cover is external validity. This is how well does your study generalize to other studies, to other findings. We often call this ecological validity as well. And we want our research to be high in external validity. However, there's a trade-off. If your study is high in external validity, it'll be low in internal validity, and vice versa. If your study is high in internal validity, it's low in external validity. So for high external validity studies, these are usually correlational. We usually do survey designs or doing it in the field. Those are high in external validity. They're very good at generalizable because they're not artificial. However, there's no very low internal validity because you're not manipulating any variables. Now, laboratory research is great and high in internal validity. However, since it's so artificial, you're lacking external validity. So it's so artificial, it's hard to extend that to another study. Thanks for watching, and I'll see you in the next video. Take care. Bye-bye.